AI Agent Game Dev, the dev squad is actually multiple agents working together to build multi-file games. Here it has also simulations. Here it has built an ant colony simulation, for example. As you can see, as the ants find the foods, these little green dots, they lay pheromones and other ants follow. And if you watch here, the food collection actually gets uh, increased as more ants actually find the food. This is pretty interesting. It also created a bird flocking simulation using both. Here we go. There are obstacles. There's the flocking behavior and directionality. You can also add predators. You can actually increase the size of the flock as well. There are also some other options. So this is again multi-file. And let's take a look at Farm Frenzy. So this game has some. You can just plant different types of crops, and depending on the conditions, they actually grow faster or slower. And here is your money at the top, and the conditions are here. The font is not the greatest, and when they're grown, you can sell them, and that goes back to your. It can also build like simpler games like space shooters. Let's play this one. It actually created nice graphics. It's instructed, the system is instructed to use only in-game generated assets. So the system messages become really important. I believe you just picked up. Oh, I crashed into an enemy, so that was game over. Yeah, so I have two files for this. One of them is Agent Game Maker, about 500 lines of code, which solely uses the latest Sonnet. And I made an iteration on it, which can build more complex stuff, which uses O1 for planning. And there's different XML structures to plan the game, both complex and simple structures. So we will be reviewing the code, but the code files will be available at my Patreon. If you do decide to become a patron, you won't only have access to this, but over 300 other projects. And you can find all of them at my website, echohive.live, along with their free videos. And if you're a patron, you can find the code download links there easily. So before reviewing the code, let's actually go ahead and run the Agent Game Maker to see how the process actually works. When you first run it, you get a warning that the script will automatically execute code on your machine. To run the game and fix any errors, you have to read this and accept it. You can actually pick up on existing projects or create a new one. The special part about this project, this agent system, is that each one of the files are actually generated with a separate agent in parallel who has no knowledge of how the other files are going to be. So it's a bit of a miracle that this works at all. All they get access is to game plan information. So they each write their respective files without knowing what the rest of the files or the final game is going to be, other than knowing what this game plan is. So this is a really interesting implementation, also speeds up the development process. Let's go ahead and select 0 to create a new project. And then we can actually ask for an ant colony simulation. These always turn out to be interesting. And it asks you for how many planning iterations you want. So there's a planning iteration where two agents discuss the game, and then there's, after their discussion is done, there is the game plan agent that actually generates the game plan. The game plan is saved under the folder that is being created. So currently the agents are discussing. After that, we will create the folder structure, and then the game plan will be generated. Here we go. The ant colony simulation folder was generated, and the game plan was generated with an overview of mechanics plus the description of each file. So now the files are being generated in parallel by separate agents. So far, 7 agents have worked on this. And after these files are written, the 8th agent, the error correcting agent, will kick in, because right after these files are written, we will automatically run the game. And we encountered an error. Now the error correcting agent is going to go to work and try to fix this error. While it's trying to do that, I'd like to talk about my website a little bit more. These are all my YouTube videos, but my website comes with a neat search videos option, so you can actually try to search through and find the content you're looking for. Also, you can browse them easier. And if you do decide to become a patron, you'll have access to all the source code for all of these projects. I also have the Agentic dev team. which actually is designed to create any Python program, not just games. So this agent quad is actually is an improvement to a previous version that you may have seen a few months back. Okay, the game is running now. As you can see, it's actually running slower, and these two ants have found the food and they're leaving pheromone trails. So you can, now that the game is running, you can actually close this. I mean, it's up twice. I'm not sure why. It starts going to taking user feedback, so you can actually enter your feedback, and it will actually improve the game by picking whichever files needs improvement, and it'll also engage an error correction phase as well. So it's a neat little system. So now we can start reviewing the code. But remember that you can always download it from my Patreon. And I built this game entirely in Cursor, which is, I believe, the best code editor. And I have a 1000x Cursor course for this. You can find the link from my website. I do highly recommend it out. There is 28 chapters to it, 27 chapters, over 18 hours of content. I'm sure you find it very useful. Okay, so let's begin by reviewing the Agent Game Maker, and then we will go over the Agent Game Maker with O1 Planner as well. Okay, so just bear with me because there's going to be a lot of code to review. Here we are using async anthropic, and we're going to use the 3.5 latest sonnet. Print response is set to false. If you set it to true, you'll actually be able to see the responses as well. There's a warning saying that this will actually execute the code, the written code automatically. There's going to be a print statement as well, which you'll have to accept. There's a list existing project folder, which is going to loop over all the folders and list them and return the projects. So you can actually choose if you wanted to continue from a project. And this is going to print them in an enumerated list. And in the main function, we are going to print some welcome statements and display the warning and accept user feedback there, list the existing projects, and then we are going to ask to whether to continue from a project or select 0 to start a new project. This while loop will break if you start a new project, because the other main loop will kick in. So in the create the game loop, we will handle the feedback and error correction for existing projects. The max attempts is set to 10 for error correction, but it'll manually ask you to continue error correcting if you want. So you do want to keep an eye on it. We will enter another while loop here. This is to continue from existing projects. We've just run the game, which we will review this run game function soon. And if there is no error, because we will receive the error. If there is none, then we're going to go into taking user feedback, update the game files, and then count the lines of code and print them to the user. If there are any errors, then for max attempt of errors, we're going to try to fix the game files and count the lines of code again. So you, at all times, will be able to see how many lines of code the game is. If it fails to fix the error for 10 times, we're just going to print and ask user to continue error correcting by pressing enter. We are going to have a function to sanitize the folder name so that we can actually create the folder names based on what the user has entered with the first 30 characters of the user input. And then we are going to have a function to get the next available folder name based on user input, because we will also have a enumeration strategy. For example, if you ask for the same exact game twice, it'll be able to create enumerated folder structure. So that's nice. There's a function to check for consecutive user message and add a separator, but this is no longer necessary with Cloud API, Anthropic API, I should say, because previously you couldn't have two of the same role consecutively in the messages list, but actually that has changed, but I've left it in there just in case. Here's the function to call Claude, which is going to take in a system message, user message, and max token is set to 8,000. So this is pretty self-explanatory. Oh, so here is the update the agent write file to use the new help. So this is the agent write file. These are going to be the agents that are writing the files. So it system messages that you're a Python game development expert. Your task is to write error-free Python code. So we have quite a few system messages, so I'm not going to read them all, but essentially, if you read through this, it is designed to hopefully generate the best possible game. But this is by far not the best one, probably. So this requires, if you do download the code or build your own, make sure that you experiment with each one of these system messages. So we also, so this is the system message, but we also have a prompt, create a Python file name. We give the file name with the following description. We get these descriptions from the game plan, as you remember, the description. And also we pass the entire game plan as well, and also some logistical stuff, such as the game should always start with a main module within the main.py. Then we call cloud, get the code, and then we write them to the appropriate folder in the file name. Now, here's the part where we are actually planning the project. This is the system message for it. So this is one of the system messages. We have two system messages for two different agents. This one is a logical critical game design expert. I would recommend you pause the video and actually read the rest of it, takes in the user input. The second one is a logical critical architecture expert. So this one actually is more critical of the two. So this one kind of designs it, this one reviews it. So you can think of it like that. And we also pass in to both of them taking the user input. And we also have another message that says plan a Pygame project based on the user input. We always say that the game should start with a main module in the main.py file. And for however many planning iterations you have specified, we enter this. And if we are at the final iteration, then we add this message saying that this is the final iteration. Please provide your final game structure along with the file structure you think is best for the game. And so this message will actually go in there to generate the final message. Actually, this is probably not needed because I think this is the correct one. Although this is we are adding it twice. I exactly can't remember why I did it this way, but we called add separator between consecutive user messages to remove consecutive of the same roles. Like we said, this is no longer needed. Then we call Claude and we append the appropriate usernames for each one because if it is the first agent, then we add the second the message from the second agent to it as an assistant. Otherwise, append it as a user. So you're this, because the two agents are talking, and one of them is going to be an assistant for the other one, and one of them is going to be the user. Anyway, so if it is final, this is the final iteration, and we say review the game and provide your final response in the XML format. So this one actually just uses a very simple description here, but as we're going to see, we actually have improved this on the next iteration of the file. Again, you can read this through, and the rest of the message logistical situation here. And then we extract the XML content and then we just return it. And just in case if any one of the code blocks have a triple backtick Python in it, which sometimes can happen, we are actually removing them before writing it, returning the code before writing the file. Function to parse file structure from planner agent's discussion. This is to extract the XML and parse it out of the response. Run game function is going to initialize a file output, full output, and full error output because we are going to run the game with sub process executing the main.py's main function inside the file. And if we receive any output or error, we're going to populate these empty strings. So we run it and we append any output or error into the full error, and we're going to return that unless the game breaks and unless the game doesn't return any errors. And we return this from this, return the error summary or return none. And here in create game function, we have to max 10 attempts. We're going to run the game, get an error summary, get feedback. Actually, this is repeated as well, I believe, at the top. We probably don't need it. So when I was building with cursor can leave some of the functions untouched. So actually, maybe this requires a little bit of cleaning. But anyway, this is the same thing. We run the game, get the error summary. If there is no error, get user feedback. Otherwise, get the error summary and return it. Um, yeah. And fixed game files is going to try to get the errored file names, although I think this wasn't necessary from the error message. And essentially we're trying to get the files that caused the error, but we are actually going to be sending all the files for review anyway. So we grab the file contents for each of the files, and then we create a new system message. You're a Python game development expert. Your task is to fix errors in Pygame projects, and then analyze it, provide reasoning, and then return the corrected file contents, just like this, in XML tags with the file name plus the corrected file content. And we pass the error message and we pass the file contents and make a call. Mix tokens should be 8,000. And then we print the response, and then we write over the files that are corrected, and then we update the game files, prepare the prompt for API. Here are the, so this one, oh, this one is for actually processing user feedback. So we again pass all the contents of all the files and pass in the user feedback, and then we ask for an updated content. This doesn't have a reasoning step, for example. Maybe adding a reasoning step here would have been nicer. And this system message is for the updating the game based on the user feedback. You can read the rest of it here. So there's quite a lot of system messages, and all of which are probably can be improved. And this mix tokens also should be 8,000. And I'm just realizing that we are actually using the alt sonnet in some of the time. Okay, so let me go ahead and actually fix that because we are defining the model up here. So this, okay, see, it goes to show you do have to pay better attention. Let me fix this real quick. But this may have actually worked so much better, actually. And I fixed this. I must have missed it. Anyway, so main function to orchestrate the game creation is the create game function. We take in the user's feedback to describe the game and ask how many planning iterations that we want. And then we get the pause next app folder created, plan the project, get the final plan, create the folder. Sorry, this is to get all the app folders that are present. Then we want to create the app folder that the app name was found for, and then save the game plan in the app folder. Get the file structure out of the file plan, and for each file name, file description, and the file structure, we create and execute. We create the tasks, calling the agent write file function appended, and we call it with async.io.gather in parallel. So this is the most crucial step right here. We count the lines of codes and run the game in a loop to catch and fix errors. We call the run game. So as you can see, this is repeated multiple times. This is my bad, but essentially we could have just called that function above it here, but this is to run the game and get, if there is no errors, get user feedback, and then fix the game. So let's also take a look at the one that actually uses O1 for the planning iteration. So this is going to be largely the same, except this has the option to use O1 for planning. If you set this to true, we will use OpenAI's O1 for planning. Otherwise, it will revert back to Claude. So there are also some other differences here. For example, we have two different game plan strategies. One of them is simple, one of them is more detailed. And if we have actually set O1 use to true, then we automatically set use detailed XML to true. Because the reason is the Claude is great, but it can be lazy sometimes. And with a very complex XML template, then it can get lazy and doesn't return all the aspects of it. So, but O1 actually has no problem. So therefore, I automated that process of if only when selected O1 for planning, then did we use detailed XML. And there's also an optional review of game plan, which is set to true by default. So there's the planning phase, right? When two agents discuss the game, and then they generate a game, and then finally a third agent generates the final game, but final game plan. But if this is set to true, actually, that is not the final game plan. That is the preliminary game plan. And we get O1 to actually review it and try to improve upon it. All of this is to try to make the game run correctly the first time around. Does it do that? Not so much, because the reason is O1 actually creates for way more complex folder structure, I mean, file structure for the game. Actually, it builds, it makes for better games, but because it is more complex, so then we actually run into errors. But Claude is very good and is able to fix the errors at 3 or 4 tries max. And the games that are built like this actually are much more complex and also uh, quite often over 1,000 lines of code. The thing to remember, I suppose, is that with better planning and better reviewing, the games do get more complex, and O1 is just so great at those things. So this has been an experiment that is teaching me the value of using the O1 style thinking models in these types of processes. As you can see, the simple game plan XML just returns an overall game plan along with the simple file names and description for each file. And the detailed XML actually returns for each file a file name plus a purpose, imports list, classes, methods, and all of that. So it's just a better one, and all of these can be improved. So, and also the system messages for each agent has also been improved with additional critical constraints and also addition of 16-bit graphics. So if you take a look at both, and I'll go over each one, you'll see that there is quite a lot that can be done with the system messages, although evaluating system messages become a real problem. Because if you were to ask, for example, AI to write these instructions, which seems reasonable, then they can introduce unwarranted complexity, which may actually hurt the games that you're trying to create, but it can also help it. So, and evaluating it becomes a bit difficult. You just have to kind of eyeball it because this takes quite a long time to write a single game. I mean, how many games you were going to write to really evaluate? So you just have to have a feel for it. Again, I'll jump to another um, example of one of the instructions if you want to take a look at it by pausing. I won't go over the entire code because this is largely the same, but I will go over the instructions if you want to pause. See, this has key focus areas and has better instructions, and just overall does better. Again, we have some parts that still don't use the model, so I will go ahead and fix those as well. Okay, I've done that, and I'll update the code files in Patreon. Like I said, you can download it from my Patreon, and if you do, I appreciate your support. You can find all my projects at my website at GoHive.live. When you become a patron, you have access to the source code of all the files. If you become a $30 patron, then you have access to most of them. And if you become a $50 patron, then you have access to all. As a $30 patron, you also get access to my cursor course with chapters and over 18 hours of content. You can actually watch the first 2 chapters for free and preview each chapter for 2 minutes. I also have consulting tiers at my Patreon if you want to talk to me one on one, or if you need help with your projects, consider those as well. Those are at the membership levels where you can find at my Patreon page. Thank you for watching. I hope you found this useful and see you in the next one.